Yeah. There we go. Now I can share my screen. And yeah, it's only a few slides long, but the first slide I meant like as a little bit of an overview of how I essentially pick my exposure times with a mono camera, and but it's basically the same thing with whatever camera you're using. But really, it's only a semi-science. You have to do it a lot of experimentation and feeling, but really for a moderately bright target with some not huge stars in it, you really want to find a base exposure for your camera with a given gain. You really want to find your benchmark, and then once you achieve that benchmark, you can find what is an appropriate exposure time simply by using the ratios of your equipment.
So David, do you do that on a filter specific basis?
Well, filters are one of the things you do on your ratios.
Okay.
Screen.
So maybe you can find your max exposure and then develop factors for your filters, perhaps, or.
Well, I'll tell you about that. Just don't jump ahead, Dave.
Okay.
So really, unlike a daylight photograph, you really want to expose to the left-hand side of your histogram, and more so than the right-hand side. Really, you want an exposure where you're not oversaturating or blowing out the stars. Okay, so if your stars start being saturated in the center, and yeah, it's okay to have a handful, half a dozen or so, that stars that actually get saturated in the middle. And sometimes when there's really bright stars, you really can't avoid it. But you really want
sound attack.
Yeah. You really want as much as possible to avoid getting a lot of saturated stars. Okay, and especially with Star Exterminator and Blur Exterminator, where these programs are looking for the profile of your stars to identify stars. And if you chop off the tops, if you clip off the tops of their brightness profiles, there's a chance that you won't it will miss them and interpret it as not a star, which can cause some difficulties. And you also want it, so if you want it that large, you have to back off. Unless, of course, you're going to throw out the stars anyways. If you're going to throw out the stars anyways, you might be less concerned with this. If you're adding RGB stars to a narrowband image and you're just going to remove the stars from your narrowband image anyways, you might want to expose it a little more to get a higher signal to noise ratio on your object you're taking.
So you could maybe do a separate sequence of the stars to get good stars, right? You could focus maybe just on the deep sky exposure, and knowing that you're going to get rid of the stars, and then do better star exposures later.
Yes, exactly, with your RGB filters, for example.
Yeah, but David, isn't your point about if you blow out the stars, then Blur Exterminator can't handle the blowing out stars correctly?
Yes, so you don't really want to blow them out.
Not totally blown out, yeah.
Too. On the other hand, you don't want the exposure so short that what you're looking at is embedded in the noise. Okay, what really matters at the end of the day is your total exposure time. Right? Now you can take too short an exposure to that won't be ideal. You can take too few exposures, so that won't be ideal. But as long as you're in the ballpark, you'll be fine. There are some things to help you. If you're running off a PC and using Astrobin, you can actually start at your session. You can take a couple of exposures, and Astrobin will do a good job of telling you what exposure you should be using. Okay.
How does that work? I'm not. Do you submit it to Astrobin, or what
I'm
happens?
not sorry. Did I say Astrobin? I meant Nina.
Oh,
Yeah, actually,
okay.
SharpCap does the same thing. Glover actually built that into SharpCap, and you can take some sample frames, and it'll give you some advice on the exposure.
I should change that to Nina.
Oh.
Sorry, I get mixed up.
Yeah, I figured Nina would do it as well, but I'm familiar with SharpCap's version.
Oh no, I'm sorry. I was talking out of my point. I did mean Astrobin there.
Oh.
One way to
Okay.
cheat is if you go on Astrobin and you say, what object am I shooting? You can do a search for that. You can search for someone shot the same object with your camera. And most of the time they'll tell you what exposures they used.
Mm.
And you can really use that as a good basis. So in that case, I did mean Astrobin. The next case, I have used Nina process to determine the ideal exposure for it. So that's the one where you take a few shots and you'll find that.
Yeah, so Nina and SharpCap are kind of empirical things. You do it at the time when you're shooting, and it analyzes it, whereas Astrobin's more like a catalog of known kind of good exposures, right?
Yes. Yeah.
So with
well,
Astrobin, you also want to make sure they're using roughly the same speed of
Yeah.
your f-stop.
Well,
as the camera.
they should tell you what gain they're using. Right? And you can judge for yourself. Do I like this picture? Did they do a good job? Right? But really what you see from there is how the total integration or the total exposure time really is the main deciding factor. One thing you should do is just examine the histogram, especially if you can zoom in on it. You don't want your histogram cut off on the left-hand side of the frame. So you want your exposures to be at least long enough that your histograms are towards the right-hand side. You've got a nice regular curve up to your histogram peak.
Speaking of histograms, Dave, there's a variety of ways you can get your histograms. I think various programs, Fitz Liberator and other things, generate a histogram. What do you use?
Well, Nina gives it to you frame by frame. So
just like SharpCap does, Reg.
Does
like,
ASI Air do that or no?
Yeah.
Yeah, it'll do that too. They all do.
histogram.
They all do.
Yeah.
So whatever you're using to take the pictures should be able to give you your histogram.
I think Darren's politely waiting to ask a question
I have
there,
a quick
and everyone
question.
else is
No,
barging
sorry.
in.
It's
Sorry,
all good.
Dave.
I have a quick question. How many exposures would you generally take? Like 30
I'll get
per
on to
filter?
that.
Okay, I didn't know if
get
that
on
was.
to that. Yeah. So of course there's camera considerations, and I'm going to talk a little bit about that, environmental considerations, and some situational considerations. First, on your telescope, really the thing to remember is the ratio of your f-stop squared is the ratio of the extent the exposure time you should be using, and it's really once you've benchmarked on a certain telescope, you can go to another telescope and you can get a feel for how long you need to expose for, how much you have to adjust your exposure time for. And really it's the one F squared divided by the other F squared. It has to do with how much light the telescope's letting in, how much it's expanding the night sky on your frame, and all sorts of things like that.
But this would at least hold your camera constant, right? In a sense, right? If you're using the same camera across two telescopes,
I'm assuming
you could use this,
I'm
right?
assuming you're using the same camera, right?
Yeah.
Yeah.
Okay. So for example, if you're going to an F10 scope from an F7, you go, it's really, you need to double your exposure times. It's 10 squared over 7 squared is 2. The other thing I like to use is the filter ratio. And you're using this, you're on a given scope and you've got your filters. And here it's a little bit of a lie, but if you can imagine if you're using narrowband, you've got a bandwidth. Could be 3.5 nanometers, 6.5, 7, and even higher kind of standard numbers for the bandwidth of those filters. And for RGB and filters, you tend to use the number 40. Number 40 tends to work. It might be a little bit different depending on what particular filters you have. And then I generally use 80 for lume. So if you're thinking about the exposure time, using the same gain, the same camera, and the same telescope, you can ratio how long you need to make the exposure time. So the exposure time is basically the base time times the bandwidth of a new filter divided by the bandwidth of whatever your reference frame that you know is a good exposure happens to be. So
What's a unit of measure, Dave, for the bandwidth? Is it nanometers?
Nanometers, yeah.
So for a lume, you would say 80 for the.
Yeah.
Okay.
So in other words, for a lume filter, you might expose double what you might do for an RGB. Like I rarely do that. But we're not talking, again, I'm emphasizing we're not talking about an exact science here. You don't have to be exactly.
Pardon me.
You probably got a minute for an RGB filter. You probably got a minute leeway around your ideal exposure time.
Yeah, a lot of wiggle room around these.
A lot of wiggle room. But generally this tends to work. What you might see if you've got like a 3.5 nanometer narrowband filter, what you can see is there's 10 times the exposure. So if you're doing a 2-minute exposure on RG and B, that means you need a 20-minute exposure for your narrowband filters. Well, 20 minutes is a bit long for me, so that's where you might use gain to counter that. So there's a bunch of things that come into it, and I thought I'd just give what we would call a process flow diagram for how the camera works, because I want to explain a little bit about gain and offset, because that might be something you might want to consider when you're picking your exposure time. But basically what happens in the camera is a photon comes in and hits your sensor, and then that sensor sends out an electron in response to that photon. And then it goes through an electron multiplier that then, you might have one electron coming into this signal multiplier, and out comes 3 electrons or whatever. And this is accumulated on as a charge on a sort of capacitor-like device. That's basically an accumulator, where all the photons that hit a certain pixel have ejected a certain amount of electrons over time. That's been multiplied and then is saved on on a charge until you're finished exposing. And it's this multiplier that really controls that gain. And then this is still an analog signal over here. So what you do is you have this reader. You can think of it as just a device that's reading a gauge and translating in that into a binary number for you. And so it measures the charge that you've accumulated over the exposure and translates into it a number. It also adds an offset that I'll talk to in a little bit, but it's just a number. It adds to what the charge it read off that accumulator. Does it into binary code, and then the camera will create a file of all the pixels, different ADUs. So instead of what comes in is photons, that's translated into electrons, accumulates as a charge, and then that charge analog is converted into what are ADUs. And I can't even remember what ADUs stand for, but it's basically the U, I'm pretty sure, is units. So it's just units of charge. So it's basically going from analog to digital there. Then finally gets into your computer, and most of these processing translate your array of ADUs representing all the pixels in your camera into a decimal brightness. So I'm going to talk about the 2600 mm camera, the couple you just got, because I picked it because Ron was in the market for it. But when you look up the specs on the camera, you get a little panel that shows you this, which is trying to summarize what it is about that camera. So it basically is the brand of the sensor, the size of the sensor, and the resolution. So this is how many of those pixel sensors are in the camera. Then they show you how many bits are required or used to represent those ADUs that I was talking about. Now, it's really not that meaningful a thing. It's really a 16-bit camera in this case, which means 16 bits are recorded or used to record all the levels of ADU. Well, it's got to be big enough to include all of the possible number of ADUs. So if the camera is going to take more ADUs than 16 bits worth, it's going to count more than 16 bits worth, then the camera is ill-designed, right? So it usually goes hand in hand. So what the real important thing is down here, the full well number of ADUs that can be counted. And this is 50,000 in this case, which, yeah, can fit into a 16-bit. There's a little bit more to it than that. The read noise is important, and I'll show you that in a second. Transmit with USB. If you're doing planetary work or other work where you're taking movies, that might be important to you, but that's adjustable too. The other number I put out here, another couple of numbers that are important here, is one was the quantum efficiency. And here it's listed at 91%. And really it's an average over a spectrum, as this little graph alludes to, but it really says if out of 100 photons that hit the sensor, 91 of them will be recorded as a charge that will be read as an ADU, that can be read as an ADU. So 9 of them won't generate a response off the camera. So here's that quantum efficiency. Out of every photon that hits the sensor, 91% will result in an electron. And then as these number of charges per electron. There's 50,000 of these resulting units of charge that can be held on this accumulator. If you add more charge than that, then this can only count that high, and you'll just chop off the tops of your stars. So this will read as the well is full. Adds more electrons, it can't get more full than totally full, so you'll lose that information. In this conversion from charge to digital, you'll get some read noise. And what this is saying is the camera will generate some noise anywhere from 1 extra to 1 fewer, well, up to 3.3 extra to 3.3 fewer based on a random consideration. And it's really how much noise this thing is generating trying to read this charge. And then the 16 bits again. If you look in the specs for the camera, there are a few graphs that are presented, but the graphs aren't really, they're important, but there's some rules of thumb where you can forget the graphs, okay? So for this particular camera, it's saying that at 0 gain, after it goes through this multiplier, I'm going to switch back here. After it goes through this multiplier, for each 0.8 of electron, or for each photon that generates an electron, that will result in 1 over 0.8 times electrons that are going to use this charge. So it's like a little bit of a signal boost. It's not 1-to-1 across. It's slightly better than 1-to-1. And so what that means is, if you go up and read it, say a higher gain, say 100 on this camera, you'll see that the answer is roughly 0.24, I think it is, which is really 3 times 1/3 of 0.8. So before, if you back to this accumulator, for each electron that comes through here, this thing's going to exaggerate the signal by sending 3 electrons over to your accumulator charge. So whereas you're getting a little bit better than 1-for-1 at 0 gain, and at 100 gain, you're getting 3-for-1, which really translates into an exposure time that you can divide by 3. Okay, when you go to 200 gain here, now you're getting like 0.8 electrons per ADU. So it only takes 0.8 electrons generated here to generate an ADU. So this means, again, you get a multiplication factor of 3. So your gain goes up by 3 each time you increase your exposure time goes down by a factor of 3 each 100 units of gain you put on the camera. So once you understand that, you don't need this graph anymore, right? So you throw the graph, don't need it anymore. Just understand that if you say, I took a 2-minute red exposure, and that looked like it was exposed right. Now I'm going to my 3.5 nanometer hydrogen alpha exposure, which using my bandwidth ratio says I should take a 20-minute exposure on hydrogen alpha. But if you don't want to expose for 20 minutes per per frame, you can go to 100 gain and divide that exposure by a factor of 3. So 20 divided by 3 is 7 minutes long. So maybe you want to take red at an exposure of 0, and you want to take for 2 minutes, and hydrogen alpha at an exposure of 7 minutes at a gain of 100 or 100 higher.
Dave, regarding the gain, is the gain for say a ZWO camera different than it is for a QHY camera? Are the amplifiers got different characteristics?
Generally not. They'll all provide a curve like that. So, but they'll all be exponentially dropped like this.
Yeah, and the graphs, I guess the graphs are
It's like
the graphs are probably comparable because
like-
you've got the same axes.
Yeah.
So Reg, we probably could dig up the same curve for the QHY.
Well,
So
the
what-
QH,
what you might find is the cameras use different numbers. So instead of 0 here, if they use the same sensor, instead of a 0 here, that might be 0. Instead of 100, they might say it's 7. And then at 200, instead of 7, they'll say 14, right? It's just knowing what that scale is. And you can just a little bit of analysis of this graph. Like you can see here that this is a third of that number. This is a third of that number. If I go over to 300, it'll be a third of that number. And that's just an exponential decline. Right? It works basically the same as f-stop. It's the same. But there is a price to be paid. There's a couple of prices to be paid, but one of the prices you pay for gain is, if you remember that accumulator, now a photon coming in, say at a gain 100, is roughly generating 3 electrons output from the sensor. Well, what that does for you, this is an exponential decline here, except they've drawn it on a log plot, so it appears as a straight line. What that does is it divides how many electrons your little storage, your accumulator can keep, is dropped by 1/3. So instead of 50,000, which the camera was advertised, now you can only keep what's that? 50 divided by 3, 18, 17.
Mhm.
17,000 ADUs. You see how that works? Then at 200, it drops by a third again. So what that's affecting, this is as bright as you can make an object, which it's fine. You're losing some brightness resolution by using a higher gain. Okay. But if you're not saturating at 50,000, you roughly won't be saturating if you divide the exposure time by 3, because you'll only accumulate the 1/3 the number of ADUs by dividing the exposure time by 3. So all the numbers just sort of go around and fall into place. And you know, the key is to remember this 1/3 for every 100 in gain. Okay. There's also some, which the part I really didn't get a chance to get into, there are some read noise implications and some dark current implications, particularly associated with using gain. So you might have to redo your darks and flats. The second thing that I just wanted to mention about is the use of binning. So in CMOS, you can't really bin the same way as you can with CTV camera. I won't get into why, but essentially, because each what you're doing with binning is you're going back to our sort of camera thing. And if you can imagine this blue thing is a single pixel, what I'm doing with binning is I'm counting this pixel plus a pixel that's next to it as a single pixel. So what I've done when I'm doing that is I've increased the surface area that's being exposed to photons. Okay, so now for each sort of combined pixels, if I combine it just adding two pixels together, I'm getting twice as many photons, which means twice as many electrons, but I also have two of these accumulators. So I'm gaining my capacity to save charge. So if you want to gain some of your dynamic range back by adding a gain, you can get some additional room to count electrons by combining these, but you'll also be receiving more photons, so you'll be making your camera more sensitive, but you're paying for that in terms of your spatial resolution of your image. Okay, so I wouldn't go binning right off the bat until you're comfortable with your exposure times. And I would only go binning. I tend to avoid it in most cases. I will use it if I'm doing a mosaic, where there's no way I'm going to look at the full resolution anyways. Or if I'm way oversampled, like if I'm less than 0.2 seconds per pixel, I would go and bin under those circumstances. But really, when you get started, I wouldn't worry about binning so much. And finally, with these ZWO cameras, there is a bit of a consideration. The other source of noise in your accumulator. Well, if I just go back to that noise, that read noise for a second, this read noise, it'll be a combination of a random noise element plus a certain bias. And this is why you're taking bias dark files. Very fast exposure. You're just wondering about the error that this A to D converter is making when it's reading the charge and converting it to a number. So you'll take these very quick exposures. What is my error? And that will be 1 to 3 electrons for no light whatsoever. They're called bias because this thing, it has a random element, but it also has an element where it actually biases some of your pixels. Some pixels will read high by 1 to 3 electrons. Some will read low by 1 to 3 electrons. And it'll do this not completely consistently, but somewhat consistently. So what you do, if you take a lot of bias frames and then you average them all together, stack them and average them together, you can get rid of the random noise element, and what will remain is this bias that this converter has to the various pixels. So and then you can, once you've got that file, you can subtract it to get rid of all that bias on the frames you've taken. The second part of the noise that happens is while the sensor is recording the photons, it'll receive photons from here, there, and everywhere in the circuitry of the camera, and it'll also get some random noise from outer space, right? And this will be, excuse me, a number of electrons per second. And it'll basically increase linearly. Again, we can take dark frames, and this is why we take dark frames, is to add this all up. We take multiple to get rid of the random element, and then we can subtract this read noise from our actual frames. Now, this has got very little to do with exposure time, but I'm just showing this to you because I was talking about the camera. But the other thing to consider is ZWO cameras have this, and I don't know how they do this, but it's some I don't know if it's done with hardware or just software, but it's for some reason 100 gain is associated with a sudden drop in, well, it switches over to a different hardware software configuration, and it achieves a sudden drop in noise. So really, these are all lows. I generally shoot at 0, 100, or 200 gain. And I also have dark frames at various times for 0, 100, and 200 gain. So I haven't had the need to go to 300 gain. I think you lose too much dynamic range. You don't have the brightness resolution anymore. The other thing I just want to mention is offset. Now, Nina can help you determine an appropriate offset too. Is when you're subtracting these dark frames and you're subtracting all these frames, you can realize that your numbers can actually go below 0. So noise, you can actually read a negative charge on a sensor. Well, this will be normally cut off and set to 0 because under the ADUs, there are no negative numbers that can be read. So to capture this negative sort of noise, what we do is we add an offset, an arbitrary offset. Now, there are ways to calculate what offset you should really be using, because if you want to avoid negative numbers, you can take a picture, you can take a flat frame or even a regular frame and say, okay, how many of my pixels actually read 0? You can go to statistics and find out how many read 0. And what you want is your offset to be just big enough. If there's a number reading 0, you want to add a little bit of offset until you're not reading any zeros. Now, ZWO recommends a 50 offset for all gains. If you want to be super cautious in your dark stuff, particularly if you're going after something really, really dark, or IFN or something very faint in your pictures, you might want to use 200. I actually never have. I've just stuck with the 50, and I really haven't seen anything bad about it. But one day I'm going to investigate this. But I've seen a lot of people recommend 200 offset for the ZWO camera. Nina can help you calculate it, or you can calculate it using PixInsight or whatever can give you the statistics. But what's really a pain in the neck is if you change offset, you really need to create new dark files. So the last thing I wanted to touch here is how long should your exposure time be, or your subframe length versus the number of subs? They basically work in the same way. There's a little bit of resolution differences, but they both, if you increase the exposure time without clipping your data, there really is, you will increase the signal to noise ratio the longer you expose. And there's probably an asymptotic limit to the amount that you can do this. Like, you don't continue to improve every time you double your exposure time. You run into the law of diminishing returns. Okay. Similarly, you can reduce the noise by averaging the noise by taking multiple subs. And this is an asymptotic limit too. If you're reaching an asymptotic limit, you're averaging the noise to get rid of it. But really, after you've got so many frames, you're really not doing that much more. So really, you want to balance those two things out. The other thing, since both more subs and increasing the exposure length both increase your signal to noise ratio of your result, you really want to look at what is a reasonable exposure time for a target I'm looking at, and how much total time do I have to spend on that target? How many nights, how many filters am I going to go through? And you want to pick something reasonable. Do your ratios and say, yeah, the exposure time of this is reasonable for the noise decrease by using number of frames. I tend to key off on 20 as the minimum number of frames that I want to add together. So per filter. Right? Realizing that if I go for 20, if I want to really see a marked change in that signal to noise ratio, I'll have to double that number of frames. If I want the same change between 40 and 20, I can't just add 20 more. I'll have to add 40 more and go to 80 frames. So those numbers 20, 40, and 80, what they mean to me is those are sort of like 20 is my absolute minimum that I would need on a fairly bright target, whereas 80 frames I might want if I'm going for a dim target and I want to separate my signal from my noise. And that kind of goes into the wash with my exposure time length, which goes into the wash with what gain I want to use. So it all sort of goes in this big tumbler, and you just calculate your ratios and try and figure out what's best in all of this. So I hope that was, the other thing about exposure time, the other limit you need to be aware of is the longer you got your shutter open, the longer you're collecting those photons, you're increasing the likelihood that a plane's going to fly in the middle of your frame, a cloud's going to come in if it's like that, or something's going to happen. So I tend to keep my frames for my narrowband less than 15 minutes. Does that all help? There's some other factors that go into this. And I'd love to show you a table, but that's all that goes into picking your exposure time.
Thanks, Dave.
Yep, thanks.
Yeah, that was good, Dave. I've got going back to this idea of binning. We worked it out for the VCO scope. If you're gonna have your best scene, we're gonna get is about 2 arc seconds. And for that, for the resolution of our focal length and the size of our pixels for our particular camera, the QHY 600M, we're looking at it's best for us to do a 2x2 binning. And so that means that every pixel that we're collecting, we have 4 times as much light as we would have if we had just had a single non-binned pixels. But wouldn't that also increase your well depth? And would that avoid you from blowing out your stars, oversaturating your stars?
Well, yes and no. It does help a little bit, but don't forget you're collecting more photons. So if the star takes up 4 pixels, you're collecting more signal for those 4 pixels at the same time, right? So if you're blowing it out and it takes covers your 4 pixels, you're going to blow it out in the same amount of time. Only if the star partially covers your 2 pixels will you not. So there was a rule of thumb, and some people swear by it, that says if you're less than 1 second, because 1 second is basically there's 2 limits. One is an empirical one where someone, I think it's the Dawes limit, where someone tried to separate double stars, and that was the limit to which they could separate double stars visually. And there's another theoretical limit. But generally people will say if you're under 1 pixel per second, then you are oversampled.
Yeah.
Okay. So I know with my but I'm just from my experience, I think the number is less than 1. Because I can tell, I think I get better resolution at 1 than 1 second, even though, you know, the seeing is 1 second, but best seeing is 1 second. But I just see it in the pictures. And when you're taking planetary, you can do much better than 1
Yes.
pixel per second. So I don't buy that. I think there is a limit, but I think the limit is more like 0.3.
And my understanding with CMOS is that binning as a camera setting is really no different from taking your actual final exposures and just digitally binning them after the fact.
Yeah.
It's different than a CCD. So
Yeah,
it's better. You might as well just do everything with as many pixels as you can. And if it's a bit noisy, just change the resolution in software and you get the exact same effect that you would with changing the binning on your
that
actual
is
camera.
typically how the CMOS configuration works. In a true CCD, that's not true. In a true CCD, the binning does take place before
I don't think anyone in
it's
this
processed.
anyone in this meeting is shooting with a CCD. So
I still have one, but
yeah, are you
I
shooting
know
with
there's a
it?
difference. I know there's a difference.
Yeah.
So you can, like, it does save on file size.
Yeah, sure.
And you can drizzle and get some of your resolution back if you bin. And there's really no harm. You do get a bit of sensitivity back. I think there is a bit of increase in sensitivity when you bin. So where a typical thing to bin would be, in my mind, is if you're taking lume I would take those unbinned. And then if you're doing RGB just for the color, then bin those.
Yeah, it would make sense to bin those because the color is just you're doing it for color. You're not doing it for detail.
Right. But then there's the argument, well, you can extract the luminance from your RGB, combine that with your luminance filter,
Mhm.
and get even better noise reduction and signal to noise ratio. But
David, a quick one here for you. If
sure.
changing a little bit here, but I'm kind of unsophisticated when I shoot. So if I have a narrow band, I'll push it to 600 seconds, 450 maybe. I don't or haven't done a lot of narrow band right now, but I was just interested in, and I shoot at a gain of 101 because I'm one of the superstitious lot that 100 is on the cliff there, and you want to be on one side. But what would you use a gain of 0 for if you were going out to set up? Would that be something with a very, very bright object? Can you give some examples, or just trying to get a feel for that?
Absolutely. When you're shooting something bright, you may want to go to 0, right? You got decent darks that, it does show a drop in that noise, but if you've got decent dark files, and you're going down low enough temperature, a reasonable -10 is what I use, but you're going down to a reasonable temperature, it's really a small number. And there's people out there that say they don't even use dark files. Well, I have to. I mean, I just can't.
So if you're shooting Orion, for instance,
Orion use gain
people
0.
do that a lot of different ways, but if you shot at 0, that's going to do a nice job on the core. It's going to give you a lot of well. Is that?
Yeah, for sure. The trapezium at gain 0, you could probably do a lot better limiting the amount of blowout on those stars at gain 0.
The ones that get me really are the planetary nebula, especially if you're shooting narrowband. Seriously, in the planetary nebula, what's that little one called?
The Ring Nebula?
Cat's Eye.
Oh, Cat's Eye.
Okay.
Like you shoot that narrowband, it's brighter than any star. In the whole frame. It is, and you don't want to blow that out, right? So I would use it then. Typically, there's always exceptions, but typically I'd be at bin 100 for LRGB and bin 200 for my narrowband. It's just, that's sort of my go-to stuff. Now, I know there's, and I don't know if Cyril has this ability too, but in PixInsight, you have this option to scale your dark frames. So what I do with my camera is, if it's a colder day, I'll stick my camera in the garage or somewhere outside, unless it's raining, and we'll do it then. But I build a program of taking bias frames, so 0-second exposure, followed by an exposure of some time, and then another bias frame, then another exposure at a different time. So, and I do that. I've got a program that shoots 5 bias frames interspersed with 5 dark frames at various exposure times, running from 5 seconds to, say, 450 seconds. And then what I do after, that takes a day of just your camera whirring around taking those frames. And I dump those onto my computer, and so I'll have, say, 100 total bias frames that I've taken, and then 20 dark frames at various exposures. And then I compile all those into master darks and master biases, just an average of each of those. And then in PixInsight, what it'll do is it'll take your dark frames and your bias frames, and it'll subtract off the bias. It'll actually subtract off the bias from your dark. So all you get is the variable noise from your dark. It does this in the process. And then rather than making your exposure time equal to your dark frame size, it'll actually do a bit of matrix math and figure out how many of your dark frames actually go into, how does that dark frame correlate to your light frames? And then pick the appropriate multiplication factor to use. So those 5 span, say 5 seconds all the way to 450 seconds. It'll take your light frame and say it's 420 seconds. It's, oh, well, the closest one I've got is 450 seconds. And then it'll adjust it so that it's using essentially the right amount of that 450-second dark frame to see. So I think what is it called? They call it optimizing your dark frames. And then for at least a year, I don't worry about darks. They're just sitting there in my library to use.
I shoot my darks. I shoot at -10 for one reason, and kind of one reason only, is I can reliably get that in my apartment.
Yeah, I think
Right.
most of us.
12 months of the year when I want to shoot.
Yeah, most of us do that. I use
-20
-10.
just wouldn't do it. Yeah.
I use -10 as well, and the delta on the ZWOs is okay, but actually it's not as good as the QHY. The QHY has a very large delta, but I think the ZW only has like a 20-degree delta.
I'm up on the hill here, and I just took some frames earlier in January, and the outside temperature was lower than -10.
Well, then you're okay.
And
Does it warm it up?
yeah. No, there's no warming feature.
Yeah.
You gotta watch that then.
Yeah.
Small effect, maybe. Interesting. Yeah.
Yeah, I guess that does save some time in literally having the darks being exactly the same exposure as the lights. But I have heard that some cameras that doesn't really work for, and I think anything that is no amp glow is fine using that method. But apparently it doesn't work very well for cameras that have amp glow. I haven't tested it, but that's what I heard.
It's more temperature sensitive when there's amp glow, but you gotta get rid of it somehow.
So I have a question. When you're shooting over multiple nights with different filters, do you do flats after each session for the night, or like when do you do that?
Yeah, I do it in the morning, when the sun's coming up, and I use sky flats with a t-shirt over my telescope.
It depends if there's any rotation or variation between the camera sensor and your optics. If there is, it's game over. So typically flats are done during the session. Well, as Dave says, very shortly after the session.
But
when the
you would do
session
it
is over.
for each filter?
So yeah, I do it for each filter.
Yeah, you
And
do.
the reason, and I tend to do it every morning after a night session. Now, if I'm really have a hard time getting up in the morning because I was doing it late, I might skip typical morning. But the reason why you do it on every filter is to catch those dust motes, right? If it wasn't for the dust motes, yeah, you really only need to take it one top.
And then
one
and
side.
then you apply the flats to the lights of the filter, I guess, when you're doing that,
Mhm.
right? Because each one would have lights and
Yes. Yeah.
flats, and then you
And actually, sometimes people do special flats, which are the dark flats, but that's another
yeah,
story.
I saw that dark flats, and I was like,
But
what's
you can use your dark library for those too, right? Which is why I take 5-second darks. Because if my flat files happen to be 10, 15 seconds long, I can always apply those 5-second darks. It'll just scale it up and
yeah,
away you go. But it's
One of
really,
the,
but because the dust modes might be different on different filters.
Yeah, and even
Why-
even rotating the wheel could flip a mote somewhere. You never know.
Yeah, well, you can't do anything about that, right?
No.
One of the guys on the Master of Pictures site says he just uses the same flats until he notices a dust mote, then he'll take new ones.
I
Well,
mean, you know, the fact of the matter is, in digital photography, we suffer from dust motes all the time, but they're only noticeable under certain conditions. Like, for instance, a regular camera, as a photographer, when I take pictures, I don't clean my sensor all the time. I know that if I photograph a uniform sky, I will probably see some of the dust motes. So I would clean it at that time. So you probably could take the same attitude for this, just like Ken says, do it when you need to. And if you do find that you get these dust motes, they're going to be more or less in the same place. So you could even retouch them if you want.
my experience though, Dave, if I don't use flats, I'll see them. It depends
Yeah.
on how, if you want your background to be totally black.
Yeah. I would say, you know, for the most part, if you're just a beginner, you don't even bother with the flats if you're just learning, right? Because it's an enhancement, right? It corrects the optical aberrations, and it corrects for dust motes.
Yeah.
it sounds like eye floaters.
Yeah,
Yeah.
same
Yeah.
idea.
Yeah,
But I can tell, additionally, I can tell my narrowband flat looks a little bit different in character from my broadband flats. I don't know how to describe it. It's not.
Yeah.
Yeah, actually, I heard that actually some of the really narrow interference filters interact with the sensor plate and actually could produce kind of pattern kind of noise.
Yeah.
That's what I heard anyways. Have you heard the same thing, Brock, or
No.
about interference filters? Because the 294, for instance, that particular sensor has this kind of weird coding aberration, and it's consistent with all the instances of the chip. So it's not like it's a particular chip that's bad. They're all like that. They have this weird modeling effect, and that makes narrowband filters interact with the pixels of the sensor differently in each spot. So that's another kind of flaw, I guess, that interacts with flats.
Darren, do you use a LED panel or no flats right now?
I've never even done the flats thing. So,
Right.
because I didn't really know when or how. But how long do you expose for when you're doing a flat? Is that a short exposure or?
So
if you got an air, it'll do it automatically for you, but it exposes to the higher end.
Yeah.
So what you want to make sure is that you want to take multiple flats so that you can do the averaging, but you want to make sure that both ends of your histogram are within the range of
Like the view,
the
it's not cut off.
not cut off,
Yeah.
right?
Yeah, the other rule of thumb people used to use is if you take the right hand side, make sure it's at least 3/4 of the way across, or halfway across. And that was a rule of thumb. But there's also been a debate about flats as well. Like, some people say that flats should never be shorter than a second. So there's that kind of thing, because they say the sensor performs differently below a second. So the flats should be more in line with the exposures that are used for the lights. So
Yeah,
there's
the
a big debate about that. Some people say 1 to 2 seconds is a good thing. That's why a lot of the light panels have illumination adjustments, or they have neutral density filters, so you can adjust it so that your flat isn't too short.
And you do the same gain.
Yeah, you want it to be the same. Well, it doesn't have to be the same gain.
No, I don't think so.
Doesn't have to be the same gain as your light frames, but it has to be the same gain as your dark frames that you're using to.
Right, because they
direct the
interact.
dark frames.
Yeah, they
And
interact.
so the dark and the light frames don't have to have the same gain.
Yes.
Right, but
The
say you're doing dark flats, for instance.
Yeah.
That's what I mentioned earlier. You have to have a flat that's aligned with the dark, right? So
Okay.
that's why they call it a dark flat. So if you, and that's why they say make sure that your exposures are greater than a second or two, and then they kind of pair it up, and they'll work together.
No, your lights don't have to align with your flats.
No, they don't.
But
But
both your flats and your lights have to align with your, in terms of gain, with your darks.
yeah, so the flat is really kind of like a gradient kind of correction, really, right? I mean, the typical things you're getting rid of are dust motes and optical aberration, right? And typically vignetting,
Yeah.
because you almost always get dim corners, right?
Big time. Yeah.
So, sorry, I took quite a bit longer than I had hoped. Who would like to show some images?
That was some good mental gymnastics there, Dave. So appreciate that. I'm in the process of dumbing it down for my own use, but
Well, really, those graphs can be intimidating
yeah,
until you discover those rules, and
Mhm.
then all of a sudden, oh, okay, it's really, that's all I have to remember is if I want to cut my exposure time by a third, triple my gain.
Yeah,
Oh,
that's actually very
100%.
useful. I never really thought of it that way, but you're right. It is all about ratios, and that's kind of cool to do, because as a photographer for many decades, I always think that way. I always think about plus minus kind of things. I think about, well, if I'm using this, then I add a couple of stops or that sort of thing. So if you kind of do the same thing in astro imaging, you get the same technique, or you can use the same rules.
Well, I always found the photographer's way of doing it by saying one stop change doubles your, or halves your exposure time, right? Or doubles your
Yep.
exposure.
Yeah, their power is O2, right?
And here's the stops you have to remember: 1.4,
Yeah, exactly.
2.2. I'm going,
yeah.
okay, that's not how I think about things.
They really should have exposure meters for the sky.
Yeah.
Yeah.
That'd be nice.
Okay. So who's first up?
I could show the pitiful shots that I've acquired here.
Yeah, and I'll follow up with
Sounds
Reg, and
great,
we can talk a little bit about the technique that we used and how we
So
captured.
you people in here, Joyce, I'm the benchmark. Everybody else is above me, so hang in there. I'm gonna try and share the screen if that's okay.
Should be. Tell me if it's not.
I'll try again. Host
Oh, no.
disabled participant screen sharing. So
Yeah,
that's-
you have to enable it, Dave.
Yeah, I'm in security.
No, just go and share screen. I think you can enable it.
No, it just wants
No?
me to share screen.
Uh,
Security, I think. Share, allow participants to share screen. There we go. You're good now.
okay. Share. I'll
Oh, wow.
Very nice.
that wasn't mine. That was a starting picture of the day.
no, it's just a teaser.
I really got off on a bad foot there. I can tell. You're gonna be all appalled. Okay, so at the VCO, we acquired their narrowband filters early this fall, I think, is when we installed them. And so David and I have been up there, and one of the objects we did was the dumbbell. And almost all of the images we caught were at the full moon, so it was not very good. So what we were using is a 12.5-inch Ritchie-Chrétien telescope, f9. The Paramount guided was guided with ZWO 290 mini guide camera, and our main camera is a QHY 600 mono, and astronomic 2-inch filters, so 6 nanometers. And basically on October 25th, we captured each filter. We captured basically 10 minutes of exposures on the 25th, 20 minutes on the 13th, which was actually a new moon, and then 10 exposures on the November 25th. We calibrated with bias and darks, but the flats that I had were unusable, and they did a lot more damage than good. And we processed it in PixInsight. So this is David. I just took yours and put them there because this was based on.
Yeah, I have a much better version of it than that, but we can look at that after you've done the rest of the
Oh, you see,
stuff.
now this is going to improve as the night progresses. So okay. So this is our sulfur image, and I used a variety of things here. At the top of here, I used a mass stretch, and a local histogram equalization, a HDRMT. But I also when I combining these things, I did something else. So you can actually see the star in the sulfur image. This is the right there is the white dwarf that's powering this um, feature. And it's today, it's the largest white dwarf known. So well, it was kind of interesting. It's about the radius is 5% the radius of the sun, and the weight is about 60% the solar mass. So that's in there. And then hydrogen alpha, and this is a case where we might have been blowing out the core here. But I'm going to play around with masking and stuff like that and getting that better. You can just see a very faint ghosting out here as well. But the interesting one is the oxygen 3. It's far more bright than the hydrogen alpha, but you can see there's there's multiple shells from the explosions coming off this thing. So the farthest out shell is along here. But this notch here is a real puzzle. Maybe you guys have got some ideas on it. I haven't really found a good explanation for that. That just shows up in the oxygen 3 filter. So then I did created a nonlinear Hubble pellet, sulfur, hydrogen, and oxygen, and I used a synth loom, and I did a little touch of noise, but it's a very noisy picture out here, and I've got a question for you on that. And if you blow up here, the one feature is really interesting is that we've got this cone of darkness here. In the oxygen, it goes right in here like a cone. It's really a puzzling thing. But in the hydrogen alpha and the sulfur, which are very similar wavelengths, this feature doesn't show up. But what
Mhm.
I was interested in is these dark areas here. And I was discussing it with David, and he was wondering if this is possibly an artifact. And I thought, oh no, I might be doing something wrong, because one of the features that I use involve wavelets and stuff like that, and maybe I'm generating a noise and that sort of thing. So I was concerned about that. But this is a picture I took from a fellow who studied in 2022. He wrote a paper on the M27. I got a real nice shot of the white dwarf in the center, but he also has these dark areas here, and so this is, I came up with an instant explanation, which the dangerous thing to do, particularly if you're explaining an artifact as a physical process. But if you've got a shell expanding out here, these darker areas, I thought might, and this is one possible thing, is that the expanding shell might be acting like a broom and piling up a bit of dust ahead of it, and that might be making a dark nebula due to all the dust that is ahead of the explosion there. So that's that. And then I wanted to raise the uh, the the issue, the difference between hydrogen alpha, oxygen 3, and silicon, because there's quite a difference in wavelength between oxygen and hydrogen, and that might affect the scattering of the light a little bit. Silicon is very similar to the hydrogen alpha. So
It's sulfur.
sulfur rather. Oh gosh, I got
Yeah,
sulfur there.
sulfur.
Yeah, I apologize.
Well,
That's shameful.
it well, first of all, when you're looking at something like that, you have to realize it's in 3 dimensions. So if there's gas, if the gas you're looking at is in between you and the UV radiation source, it will appear dark.
Mhm.
Right? Because it's actually the gas close to the UV radiation source, the white dwarf, might be glowing, but it's got to get through additional. So that notch might be just dark stuff that's between you and the rest of the planetary nebula.
Yeah, actually, Reg, I'll show mine. The notch looks different on mine, but just as a preface to me sharing my screen, I only used 2 of the filters. I don't know if I just didn't try using the sulfur, but I only used hydrogen and oxygen, and I basically did an HOO palette. And for those of you who are new, it just means that in the mapping of RGB, I put H and I doubled up on the O3 basically.
And it's a more aesthetically.
Yeah, I prefer it because it looks nicer. But do I have the right screen? Did I pick the right screen? Oh yeah, there you go. So if you look at the notch here, this is interesting because I only used H alpha and O3, and you can actually see it's different from the rest of the area of the sky.
Mm-hmm.
And the other thing I should mention is that if you remember Reg's original slide, we really didn't get that many many minutes of this actually. So I was actually even surprised that we got even this much and even this area out here. I think if we added more exposure, I think we certainly would get more detail. And the other thing I would have to mention is when I did this, I did remove the stars, and when I put them back, I don't know, I think the stars may be overexposed. But I was happy at least with this kind of detail in this area here as well. But yeah, I picked this because I find this a little bit more aesthetically pleasing than having the sulfur.
I think it's my favorite, David. That I really like yours. I just want to say while we're on this is that I did not use any of this mathematical chicanery that most of you people use, removing stars and that, because I've been kind of on the brink of going to RC Astro and buying if you buy their blur exterminator, noise exterminator, and star exterminator, you get a deal if you buy all three. But just as I was going to push send on the web, Pixen's site came out with a new version, and then I was ready to send it again, and then they updated again. So I noticed they've had some problems with some of the utilities running with the new updates of Pixen sites. So I'm holding back for a couple of days. But do any of you have these RC Astro things like Kim McGill has it? Wow.
I think many people use it.
So I'm kind of uneasy that the latest blur exterminator has a situation where it can really modify stars and eliminate coma and all sorts of stuff.
Yeah.
I think I'd feel dirty using that.
Well, it is a little bit like snake oil, isn't it? It's kind of like the substance that will cure everything. And you see the long list of all the ills that it cures, right? And the AI stuff almost seems like that. I don't know. I have mixed feelings about it.
So it's all the problem with this AI stuff, Reg, is that in 10 years it'll become self-aware and we'll all end up being enslaved by it.
Yeah.
That will cut down processing time, won't it?
It'll be you picking out the stars.
Well, Reg, I just upgraded to the latest Pixen site on the weekend, and you have to reload all the RC Astro stuff afterwards.
You have to go back and reestablish all the plugins, or
Yeah.
okay.
It's pretty simple to do.
Ron.
So when you buy it, Reg, and that goes for anybody, if you're interested and you have a NVIDIA GPU, you can make the RC Astro stuff run like that by just a few simple
Actually, I'm
modifications.
curious. Are most people running NVIDIA? I am, but
yeah,
most people are. Yeah. Okay.
I'm not, but I should be. Like Dave says, it takes like start extraction down to about a third of a second, right?
Yeah. Like
it's a very good board.
It used to be you would run one with a certain set of parameters and you wouldn't go back. You wouldn't say, did I use the right parameters there? Because it just took too long to run. So you move on. But when it runs fast, you actually say, oh, that's not quite right. Go back and rerun it again. And it makes a huge difference.
Oh, okay. So I might take the plunge with your strong endorsements for this RC Astro. And I'm glad that I held off until the latest Pixen site update then. So that saved me a bit of labor. So thanks.
Well, your guilty feeling will be overcome by the product that it produces.
Only a minute or two of remorse.
Yeah, I don't have an NVIDIA. I've got, pardon the expression, an Apple M1. So
I'm with you, bro.
Yeah, I think the M1 should do okay with it.
It's fast. Yeah.
Oh yeah, and M2
fast.
especially,
It's
right?
Fast. Yeah.
Yeah.
Yeah. I have a super fast, Ryzen ultra modern gazillion core. the NVIDIA acceleration makes a huge difference. It's just AMD
does a nice combo, like maybe something like a Threadripper or something like that, and the NVIDIA GPUs are really good.
Yeah, that's what I have.
Should I share some pictures?
Sure, bro.
Okay. Let's find that share screen button. Where is my? Why isn't it showing the application? Oh well, let's go with this. Can you see the
Yeah, it's
Very
Christmas
nice.
tree nebula?
Mm-hmm.
Going in Christmas.
Yeah. So this one was sort of my main focus during that clear time, and spent quite a bit of time on it, and it worked out better than the one I did last year or the year before, because I just actually had enough clear nights to get some real exposure time, and pretty happy with it. I've got a bit of a halo around this one star here.
Brock, I was going to ask you this question the other night when you showed this. Do you think the halation is bleeding over into the colored area and affecting it, or do you think that's part of it? Like when you
the halo,
when you see the star,
yeah,
you can see the circular halo. That's normal, right?
Yeah.
But then off to it, like just offset to the left, there's a kind of a lowering of contrast because there's kind of like a fog-like effect.
Yeah, I'm not sure. There is actually some artifacts close to the star that are actually leftovers from the star removal.
Okay. So these are known artifacts then to you then? Like
Well,
around the star that you don't
there's
think they're
some
real.
close-in stuff that's definitely artifacts from StarNet, and then there's the big halo, which I think is still just a halo from my optical system, possibly from the filter.
Are these JPEGs, Brock?
This is a JPEG, yeah.
So do you remember what I find with JPEGs make funny things when you look down into the pixel scale?
Oh yeah, for sure.
JPEGs make funny things around stars. So
Yeah.
it might
Well,
be,
it's compression, right?
Yeah, and I always use 90% quality.
Yeah.
Or you could use TIFF, I guess.
Or you can use TIFF.
Yeah. On the times when I couldn't quite get to this, I was doing some stuff on the veil just to fill time, because I didn't really want to just have the thing just sitting there waiting for that target to rise up. So I got a little tiny bit of time on the veil, which gave me this one, which it's not bad. It needs more time, but it's such an interesting area.
It looks lovely to me.
Yeah.
Yeah, it looks good.
And
Is
then
that one-shot color with dual narrowband?
Yeah, it's one-shot color and dual narrowband.
Nice.
So both of these were using the dual narrowband filter. So
what I always look for on these is that that faint shock front that's on the outside.
Yeah.
See it.
That you can see up here.
Yeah.
Yeah, there's a little visibility there.
See.
You know, before the narrowband and the dual band, triple band, or whatever band filters you want, I don't think that was very common, was it? Like in LRGB, you wouldn't see that sort of thing.
No. You wouldn't see that in RGB.
I would like to mention that at the last talk at UVic, Jennifer West, a radio astronomer, did her main focus on resolution of the radio telescopes was using the full Veil Nebula, and she did a beautiful job with that. And she started off with a photo. And then she used what it would look like using a 25-meter dish, and then using the prototype that they're using in Australia for the square kilometer array telescope that they're putting down there. And it brought a lot of different details in there, and it was really interesting. It gave a tremendous amount more physical insight about what's going on with the product, but it was a really nice example.
Yeah, I like the fact how she explained the electromagnetic spectrum, because it really drives it home. I think we're all aware that we're using different portions of the spectrum in the
Yeah.
kind of imaging that we do, but she just kind of broadened it because I don't think in the context of radio at all. So
Right.
it kind of really stretched it out a little bit for me.
It's a big spectrum.
Yeah, it is.
The I once was trying to get my head around how, like, the orders of magnitude from, like, radio down all the way into like gamma rays on the other end, and then the visible spectrum. And I was trying to get my head around how much we can actually see. And a lot of the plots are kind of misleading. But if you actually just look at the actual, 10, whatever it is, 10 to the minus 16 up to whatever the other end of the spectrum is, and you actually convert that range to distance, and you look at what we can see, and I basically scaled it to the distance to the moon as one end of that spectrum to the other. The visible spectrum is about a foot.
Wow.
So we're actually looking at the universe through a peephole.
Yeah.
That's great, Brock. I like that.
We're almost blind is the bottom line. Anyways, I also took some time on without a filter. We had the moonless period, and I liked the Crab Nebula. So I was wondering if I would be, sometimes when you do something without a filter, you actually end up with more interesting stuff. And in this case, it actually didn't turn out interesting. The dual narrowband version of this is much better at showing the different textures and stuff, but I thought I'd give it a try anyways.
Mhm.
I
So
also,
so Brock, for you, this is kind of like your galaxy mode where you don't use anything, right?
yeah, exactly.
Yeah.
You get good star color without, obviously, with just a bare color sensor. I put in my old Crab just for reference. This
Mhm.
is with the dual narrowband filter, and there's just so much more going on there. And
Mhm.
then I did a quick plate solve so I could align them.
Oh,
Oh,
you can actually
wow.
see
Look at
how-
that.
hey.
It's almost like an expansion, eh?
Yeah, although it's just the dual narrowband just brings out so much more. I was
Yeah.
trying to, just this afternoon, I was trying to play with the curves and
Well,
spread.
I guess when you think about it, the dual band is really two narrow bands, right? But
Yeah.
narrowband basically focuses light of a particular wavelength and eliminates others, right? So
Exactly.
it becomes very articulate, right?
And there's obviously a lot of broader band stuff in here that's just kind of smearing, like it's kind of polluting the
Yeah.
the oxygen especially is just so much less texture than the hydrogen alpha. So it must just be some white light that's kind of in the surrounding cloud areas. So anyways, that's all I had.
Cool.
Yeah,
Very
very
nice.
nice.
Was that a feature of the software to plate solve and it put the two images together?
Yeah, I just did that with Cyril. I just grabbed this three. I just did it quickly before the meeting. I just grabbed the images and plate solved them so they'd be stretched. It would sizes them to fit each other and also rotates them correctly.
But Brock, do you know of any good Cyril tutorials?
There's a guy that has done a ton of YouTube videos. Can't think of the name of them, but there are quite a few.
Okay, I'll hunt around. I'd like to learn it actually.
I'd be willing to, if it, I wouldn't want to necessarily do it for the entire crew, as all these Pix and Sight guys probably wouldn't be that interested. But if you guys wanted to have a separate meeting where I go through what I do, I could do that. And then
A Cyril
those-
subcommittee.
a Cyril
I'd-
subcommittee.
I'd love to hear how the other half lives.
Hey, Matt,
Yes.
can you please email me or send me the order information for that 2600 mounting plate you showed?
Absolutely.
Do you have that?
Yeah, it's All-Star Telescopes, and that I buy most of my stuff through them because they're Alberta, they're fast,
Okay.
and they use Canada. Well, not always, but use Canada Post.
Okay,
Yeah.
thanks.
Actually, they're one of the few places that sell teleview components.
Yeah. Is that enough information, Ron? You go
Yeah,
from there.
thanks.
They're pretty order friendly over your phone or computer.
Thanks.
Yeah, I would love you to do the Cyril. stuff, Brock.
Yeah.
But not next time. I'm
Okay.
not sure,
Wait.
because the last time you did it, I was not here.
Oh, right.
Nothing personal.
Yeah, I'd certainly I'd be willing to go through it.
Yeah, absolutely.
Was there a sale on the 2600 mm? Did you get a really good deal?
It was their end of year, so I got all the stuff with the 10 or 12% ZWO sale, so it saved.
Okay.
Yeah, I don't think it was an all-star sale. It was a
It's just through the
ZWO
system.
across the board
I
sale.
bought mine from ZWO in China,
Okay.
and it's on its way right now. It should be
Oh.
here by the weekend.
Good.
Mm.
It almost
Nice.
looks to me like the price has come down because I thought it used to be over 3 or closer to 3.
Well, I think
Mhm.
I think it's come down because of the Duo.
I could
Mind
see
you, the
I
Duo's
could
an
see
MC,
the
isn't it?
MC being
The
cheaper,
Duo's an MC,
but
isn't
the
it?
MM, yeah, I don't know. Maybe it's sort of a bit of a rebound from the really ridiculous COVID
Well,
pricing.
it's back up just over 3,000 now.
Is it?
Mm.
Yeah, I just looked the other day. I bought mine for 2,000 US, which is
Okay.
2,800, but that was at their old $2,600 price range.
David
Yeah,
Astro
I
has them
have I
for
have noticed that in general.
26.99.
I've noticed in general, like
Yeah.
October pricing to today, there's been some pretty big jumps. I don't know if that's because of exchange. It might be partly because of exchange.
Hmm.
And the other thing is just marketplace, because I think everything's just increasing in price.
Yeah.
Can you buy options on it?
I don't know. I'd be on the wrong side of it anyway, so
Just don't short it.
no.
Can I
So-
share some photos? But
Yeah, for sure. Absolutely.
Yeah.
sure. My first time, so let's see. Okay, so I think this actually ties in a little bit with our discussion. Can you see it okay? This is
Oh,
a
yeah.
wide screen. I don't
Oh,
know. So this was Flaming Star.
That's very nice.
Very nice.
A while ago, but what was interesting about it is I did it over a couple of nights, and so this is about, you can see in seconds, I think this is about 4.5 hours,
Mhm.
all done in Searle, and I really enjoyed the simplicity of Searle. I would say that from a learning point of view, Searle is a great tool to kind of go through the process. Basically,
Zen, can you just blow up the image itself? Expand the image?
oh, like this?
Um,
Make it bigger.
yeah, you could do that, or maybe am I looking at
Maximize the window.
two screens, or do you
Maybe
have
I'm
an
gonna go
exciting-
to my, this is I think it's because it's a wide screen, so maybe.
Oh
we'll
yeah,
stop
yeah.
there And then move to a different screen.
Oh, it's right. The aspect ratio didn't match. Yeah.
Yeah, that's not split screen. It's expanded screen,
Yeah, yeah.
landscape
Is that
screen.
better?
But we can't see it. I think you're just sharing. the
Not
one-
yet.
Yep.
Oh, that's
Oh, there-
better.
There you
that's
go,
better.
yeah.
Okay,
Yeah.
okay, so don't share widescreen, no, I know. So yeah, I did this all through Searle, and again, what's great about Searle is that, you know, you can do the scripts are pretty easy, you just have to make sure you have your folders right, and then just using GHS and some star exterminator, it doesn't run the RC Astro, that's the only negative side from my perspective from Searle, but it does do StarNet++, and so this was dual narrowband. I ran the script that allows you to split the HA and the O3, and then I recombine them in different ways.
Hmm.
So, but what I wanted to show is this is just one night worth of data, and then this is 2 nights. So in terms of just doubling your time,
No, very nice.
Yeah.
I really like that. I spent a bit more time processing this, and this is all in Searle, just using GHS and
Yeah, you controlled the hotspot in the center very well. That's very nice.
And then I did actually try PixInsight the the trial period just to kind of see. So I literally took this image, just threw it into PixInsight, and ran blur exterminator and noise exterminator, and it came out like this. And I mean, the
Oh.
detail is insane. So
Hmm.
I thought this was pretty fun little.
Were you more impressed with PixInsight then?
I like both. So again, I like the speed of Searle. Like it's really quick to get going and get an idea.
Yeah.
Yeah.
And the price is nice too.
Yeah.
Yeah.
But I mean, it has the ability to stretch it in interesting ways. It has pixel math, so you can do the basic stuff. PixInsight is great. It's very complicated. I think the learning curve is quite steep. So yeah, I think I'll stick to Pix. I'll use both. If I'm traveling, I'll use on my laptop. I'll use Searle, and just if I'm quickly on the night wanting to get an idea of what the results look like, I'll use Searle. But when I want to focus on a
So
final,
for the Cyril users, is Cyril very demanding in terms of RAM resources? Do you have to have a lot of RAM?
Doesn't seem like it. It's hard.
Oh,
I mean, it's hard. I haven't got a reference point. I don't know if it's a lot, but I've got 32
oh
gigs
yeah.
and it's fine on that, but that I've never tried it on something with
You
80.
probably have more than a lot of people do. I've got 32 as well. So
yeah, I ran it on my laptop, just not even plugged in. While I was capturing, you can kind of start playing when I was going between targets, just to get. So again, like just traveling and just ease and simplicity. I think it's not demanding at all.
no, very nice.
And then I'll kind of give you a different. I don't know how this is here. Let's see. This is now all done in PixInsight. So I think this is doesn't have a name. Some people call it the flaming skull or the question mark. I think it's too. But a lot going on here. Same process, dual narrowband. I used star, all the RC Astro stuff. I'm pretty happy with the result and the detail. I try to focus on was to kind of get all this band of cloud over here, the dark nebula, as well as the star formation area in Berkeley 59, I think that is. So yeah, this was an interesting, a lot going on, at the level of detail.
Nice job bringing out the dark stuff. That's what I always like to see.
Yeah, Zen, you mentioned Zen, you mentioned in your intro that you don't do any guiding.
Oh no, I do with this. So
oh, you do with this. Okay.
I started without the guiding and realized pretty quick. So
okay,
all about 3-minute subs. And a ton.
I was wondering why your stars were so round when you didn't do any guiding.
That's the only thing that bothers me a little bit with this image is my stars aren't perfectly round if you really but I do think that's a processing thing because in the other images with the exact same setup on that nut, I do get them round. So
okay.
I don't know if it was just my workflow that warped them at some point. So spend a little bit more time on it. But yeah, between the two, I think I like just coming back to it. I think I'll definitely use both. I think if Searle could incorporate the RC Astro stuff, I think a lot more people would use it. But that's the only limitation in my view.
Yeah, that RC Astro stuff is the one thing that's taunting me to dive into PixInsight.
Yeah. And I mean, it's just great to be able to split like double stars. Like that's the piece that I really often when I run this, I'm sitting in my living room and it's outside the door, and I do the live view on ASI Air, and as it kind of keeps building on the live stacking, just to start splitting stars is kind of fun. I like just sitting there a whole night. So
you're doing electronic assisted astronomy.
Yeah, I guess.
Yeah,
it works. I do prefer being able to set the exact parameters of what I'm trying to shoot. That's a little bit more. If it's dark early and me and my wife can sit lovely in front of the fire and it's cold outside, like it was in January, then it's great. I like the precision of being able to program your specific frames. But anyway,
what is your imaging scope, Zen?
So this was a Zenith Star 61. I did
Okay.
on the flat, so I forget what exactly the F ratio is on it.
It's probably an F4 with the reducer, I would think.
5.9 multiplied by 0.8, so I think it's 4.3 or something.
4.3, okay.
But yeah, it's a great little scope and it works really well. Very easy. I think I simplified my my capture process by using all the easiest components, like really simple to use scope and really simple to use camera.
Yeah, I think the biggest problem initially is if people don't have a go-to mount, then that's a bit of a damper, actually. I mean, it's hard to find some of these things if you're just relying on plate solving or you're just using a tracker.
Yeah.
Yeah.
I will say I'm surprised by how much detail you can actually get with the one exposure. If you in the ASI Air, at least with the dual narrowband, when you
Mhm.
you can actually do some framing with just one or two exposures and then move it around to try and get whatever framing you want. I was surprised that you could
What
get that.
filter do you have, Zen?
This is an Optilon, Alan
Okay.
Yeah, so dual.
L enhance or
It was part of the package that I got with one of my first.
right?
Ah, right.
Mm.
Yeah.
Yeah,
Well,
it seems to be a couple of camps there. I mean, there are NBZ people, and then there's the L enhance people, the Optilong people.
I think they're both good, and it's just to choose one and move on.
Yeah.
I think they work.
Zen, you're using a ZW0533 camera there, is it?
Correct, yeah.
I kind of like the square format.
Very retro.
Oh, that's good.
Yeah, I don't know what to think. It caught me off guard the first time I looked at it. It didn't feel natural. Just I think we're just used to the
Yeah.
idea these days. But other than that, I can really recommend it. And they were really cheap in December. I think they were 20% off. So
Nice.
That's fantastic. That's just
Well, you know, that could give you an advantage in some ways. Maybe you'll come up with some nice, unique compositions because it is square.
well, they say it's also good to use for mosaics if it's square.
Yep.
So that's a good. But I want to stick with this for a while. I think I've already broke the budget already with all the stuff, but I'm very excited to try to do the monochrome next.
Mhm.
I'm very excited to get there, but I want to run this workflow to ground first. So give me 2 weeks. Okay. Well, thanks for your feedback.
Well, thank you.
Mhm.
Those are wonderful.
Hey, great pictures.
Yeah, you seem to have moved quite a bit in almost exponential speed since I talked to you a couple of months ago.
A lot on YouTube. There's a lot of decent resources, and I think it's a bit of luck. I think as well. Like just if you get into like, yeah, I want. Yeah, I think it's lucky mostly. I didn't run into any major hurdles, and so it's nice to have images. And if you have images and you can start playing, then you can refine. So you can kind of get to the point where you can refine. I think it's tough if you struggle to get enough exposures to begin with.
No, it's good that you had some, quick successes right away. That's a great thing.
So are you set up to post these on Zenfolio?
Yeah, so I put a couple of my
Okay, great.
previous ones in, and I'll put these new ones in the next couple of days.
Nice.
I've got a question for you, Zen. Did you mention that you were in the Prospect Lake area? Is that correct?
Yeah.
Have you run into Cameron Burton?
He lives across the road from me. So.
They're next door neighbors, Reg.
Yeah.
Oh, excellent. Good.
No, I walk past his house to go fishing on the to access the lake. He's got a nice little lake access right next to his door. So I see his little observatory. I was here the day that they delivered it, and we had no idea what was happening, but it was quite the scene with trucks and moving it in. So he made quite the impression on the neighborhood doing that.
Zen, do you also use GIMP as well, or some
I
other
didn't use
Photoshop?
GIMP.
No.
No, I have no experience in that. So
Do you use Photoshop?
no.
Okay.
I don't have any photography background or skill, so that was a bridge too far for me.
Okay.
Me too.
Yeah, it's interesting, people's techniques. Like I'm a imaging tool editor and I'm a Photoshop guy. I always finish in Photoshop just because it's my native image editor, right? I've used it for close to 40 years. So you use what you know, right?
I use Cyril up to the point of it's all stretched and it's separated starless and stars, and then I open them in GIMP as layers and then redo the combining in there.
Yeah, so your GIMP is like my Photoshop.
Yeah.
Is GIMP easy to learn from scratch?
Oh yeah. Yeah, it's reasonably easy.
It's pretty decent comparatively. And when you look at the cost of the Adobe product now, it's I don't know whether you would today if I didn't have the bias of having a history with it, I probably wouldn't be using it.
Yeah. I used Adobe for about 20 years and then I dropped it and started using Affinity.
Yeah, I've done that as well, but I've not dropped Adobe. I still pay for the Adobe
Yeah, I
suite.
just got tired of paying for it.
Yeah.
Even though work could pay for it, I was just like, no, I'm just their prices are too high. So
Yeah.
it's almost as much as more than my cell phone. I was
I
like,
know.
how could I justify that? Internet costs less than the Adobe.
I'll tell you, my annual fee is almost 1,000.
Yeah,
It's 9
That's-
something or whatever.
I know.
So
My whole internet subscription costs less than that. I'm like, that I just can't justify it.
I have to say goodnight, you guys.
Yeah, it is getting pretty late.
good night, Reg.
Thanks,
You
Ron.
know-
Good night, Ron.
Thank you very
Good night,
much.
Ron.
Yeah,
Thanks, Dave.
great session there, Dave, and thanks for doing that talk and recording it. I'll watch it multiple times. So
Okay.
Yeah, so I'll see some of you tomorrow night at the Makers,
Mhm.
and we'll kind of look at all the compute platforms.
Thanks. I'll try and join you next month, but if not, Rocco.
I'll
will
take
get-
over.
Okay, good night.
Cheers.
Good night, everybody.
Night.
Night.
Yeah.